Hello, what's up? I'm Kelvin representing Architective, and today we'll be talking about logic gates. I'll be putting you to what logic gate is all about, where we'll be talking about different type of logic gates, your uses, your applications, where they are used. Now, is logic gate. Now, these logic gates are physical electronics device implementing a Boolean function. This means they perform logical what type of logical operation do they perform? We are still coming to that. But first, let's think about the types of logic gates. The first type of logic gate is the AND gate, the AND gate. The second is the NOT gate. The third is what we have the OR gate. You can say it OR gate. Now, let's come to the one we call the XNOR gate, and it's also called the exclusive NOR gate. Wherever you see the X in front of any gate, you call it exclusive. So for the XNOR, it's also called exclusive NOR gate. Now we also have what we call the XOR gate. Like I said earlier, wherever you see the X before the or in any gate, or before the NOR in any gate, you can also call it exclusive OR gate. Now we also have what we call the NOR gate. NOR gate. So lastly, we have what we call the NAND gate. These are all gates you really want to understand. You really want to know how they are being used in your computer systems and in every gap gate you have there. Now sit back and relax as I take you through all these gates one by one. Let's recap on the definition of logic gates. Remember, logic gates are electronic device, which means they use electricity to perform Boolean function. But what the heck is Boolean functions? Wow. Now, what is Boolean functions? Boolean functions are logical in terms of true and false. Or when we talk about the yes or no. I know you still don't get it, but okay, don't confuse. Now let me take you through an example. Let me give you an example. Now take this example. If, for example, I will call Mary if she texts me. Now listen to that statement. I will call her if she texts me. From this statement, we can conclude that I will only call her if she texts me. But what if she don't text me? Then why the heck do I need to call her? I got no business to do with her if she don't text me. Now, as human, we can understand this statement, but how will our computer system and other gadgets understand this statement? Remember, computer is garbage in, garbage out. What you give to computer is what you get in return using a program. Now, how will a computer system understand these things? These are why logic gates are created, so that logical terms can be what? Be explained and can produce an accurate and perfect answer. That is why at times when you press a particular channel, if you press channel 1 in your remote, you won't be getting any other channel apart from what you're getting. Except your remote is not malfunctioning, like producing something you're not imputing. Now, let's talk about the first type of gate, the AND gate, the AND gate. What the heck is AND gate? This type of gate give you a positive output when the inputs are both positive. We can also say when the inputs are. Now, talking about the logic gate, well, let's think about the truth table and the design, or what we call the logic design. Now, if you look at this logic design, AND gate is just like a switch. When the two wires meet, the two wires must meet. That is when it's on. That is when you also call it true. That is only when your light will come up. Now, when this A and B are both met, the X from the logic gate, from the logic design up, will be met. That is when you get an X positive. When A is positive, B is positive, that is only when S can be positive. From the truth table, you can see it. The first sign is 0, which means off. Second, B is 0. When A and B are both off, then your S will not be positive. It will still be off. You can call O off. or you call it negative. You call one positive or on. Now when A is negative and B is positive, you're still getting negative. When A is positive and B is negative, you're still getting negative. The both, like A, the last one here, A is positive, B is positive. That is only when and only when you can get a positive in an AND gate. Now let's talk about the OR gate. This type of logic gate gives you a positive output when one. Remember, have you ever tried using the statement or? It's like, I will go to Lagos or Calabar. So you're either going to Lagos or you're going to Calabar. You cannot just go to Lagos and you'll be in Calabar at the same time. Or is just a kind of differentiator between two things of choice. Now, OR gate, this type of gate gives a positive output when one or both inputs are both positive. Speaking of OR gate, let's talk about the logic design and the truth table. Now, this is the logic design of OR gate when A. But one thing you should notice, the logic design for AND gate is different from the one of OR gate, and all through they are all different. So learn to understand your drawing. Now, when we're talking about OR gate, when A is positive and B is negative, it can still give us a output. Now let me explain it with the truth table. Now, when A is negative, B is negative, it will give us X will be negative. Now when A is negative, B, what we need from this OR gate is one or both of them must be positive before we can get a positive. Now, for the sake of getting bored, I guess I'll stop here for today because I don't want to bore you with a lot of tutorials so you won't start cracking up your brain. And please, don't forget to check for the chapter 2 of this topic, logic gate, where I will explain the rest of the type of logic gate for better understanding. And don't forget to subscribe on my channel. All you just have to do is click the subscription icon and then you click the bell notification for more videos ahead. Thank you.